Welcome back, guys. So in today's video we'll determine whether an array is a subset of another array or not. So for this we have given two arrays, that is array 1 and array 2. So we have to check whether array 2 elements is present in array 1 element or not. So basically this is a subset. So we have to determine whether this subset is present into the array 1 or not. So for this there are various approaches. So let's just discuss from the very initial approach, that is brute force approach, then we'll see a better approach, then at last we'll see an optimized approach. Okay, so the very first approach that comes to your mind is a brute force approach. Okay, so what we'll do in a brute force approach is that we'll just traverse the array 2 one by one and we'll check for that particular element into the array 1. Okay, so let's just see how we can do this. Let's say at first I have taken 11, so we'll check for 11 into the array 1. So yes, 11 is present. Okay, then we'll increase our traversing, then we'll check for 3. So yes, 3 is also present into the array 1. Then we'll check for 7. So yes, 7 is also present into the array 1. Then we'll increase our traversing into the array 2. Then yes, then we'll check for 1. So 1 is also present into the array 1. Okay, so like this we have to traverse the array 2 in linear fashion. Okay, we have to iterate through array 2 element linearly. Then we have to check for that particular element one by one into the array 1. Okay, so this is a brute force approach. If we found all of the elements of the array 2 in the array 1, so we'll return 1, and if we haven't found one of the element, so we'll return 0. Okay, so that is the brute force approach. So let's just see the pseudocode for this. This is the pseudocode of the approach that we have discussed, that is by brute force approach. Okay, so here I have initialized a boolean function that will return true or false. This is array 1, array 2, the size of array 1 and array 2. Okay, then I have initialized two variable, that is I and j, for just for iterating through this array. Okay, both array. Okay, then this is the loop for iterating through this second array. Okay, we'll take first one element from the second array, then check for that particular element into the array 1. Okay, so if it's present, then we'll come out of the loop, then we'll check for another one. Okay, so like this we have to check, and if all the elements are present, so we return true, and if one of the element is not present and we have analyzed all the elements of the array 1, okay, for that particular element, and if it's haven't found, so we return false. Okay, so this is a brute force approach. So the time complexity of this brute force approach will be O of m into n, that is the size of first array, then size of second array. So and the so in the second approach we'll use sorting and binary search logic. Okay, so for this we'll sort our first array. The very first method will sort our first array. Okay, so after sorting, our first array will look like this, that is 1 3 7 11 12 then 21. Okay, so after sorting, our array 1 will look like this. Then after sorting, we'll just check for one element of the array 2 into the array 1 by using binary search. Okay, so at first we'll take 11 from array 2, then we'll check for that 11 into the array 1 by using binary search. Okay, so we'll apply binary search into this array 1 element and we'll look for 11, if 11 is present into the array 1 or not. So if it's present, so we'll return true, if it's not, so we'll return false. Okay, so like this we'll check for all the element one by one of array 2 into the array 1 by using binary search. Okay, so the time complexity of this approach will be O of m log m for sorting of the first array, then for iterating through this array 2 one by one into the array 1 by using binary search. Okay, so for binary search, the time complexity of binary search is log n. Hope you know that. Okay, so the time complexity of binary search is log n, and we'll search for that array 2 element one by one into the array 1 by using binary search. Okay, so time complexity is this. Okay, so this is not very optimized. Okay, this is better approach, but this is not very optimized. So let's just see the optimized version by using hash. By using hash table we can optimize this. Okay, so let's just see how we can do this. So the optimized version of this will be by using hashing. Okay, so we'll just initialize an hash set and we'll just store our array1 element into the hash set. 11, 1, 13, 21 and 3 and then 7. Okay, so at first we have stored our array1 element into the hash set, and then we'll look for the array2 element one by one into the hash set. So first of all we'll just take 11, we'll look for the 11 into the hash set. So yes, 11 is present into the hash set, so we'll just check for another one. Okay, then we'll check for third, that is 3. So yes, 3 is also present into the hash set. Then we'll look for another, that is 7. So 7 is also present into the hash set. Then we'll look for 1. So yes, 1 is also present into the hash set. After doing this iteration, we have found that all of our array2 element is present into the hash set. Okay, so we'll return true. So what we have done is that we have at first we have just stored our array1 element into the hash set, and then we'll just iterate through this array2 element one by one, and we'll look for one element into the hash set. So if the element is present into the hash set, so we'll return true, and if one of the element is not present into the hash set, so we'll return false. Okay, so the approach is very simple by using hashing. Okay, so let's just see the pseudocode for this. So this is pseudocode of the approach that we have discussed by using hashing. Okay, so at first I have initialized a function. This is the array1, array2, the size of an array1 and array2. Then I have initialized a hash set. Then I will just traverse to the array1 one by one. Okay, then we'll look for if array1 element is present into the hash set or not. If it's not present, so we'll add that element into the hash set. Okay, so one by one we'll add all the element into the hash set of the array1. Okay, then we'll look for then we'll iterate through the array2 one by one, and we'll check if that array2 element one by one. Okay, so if that array2 element is present into the hash set or not. So if it's present, so we'll return true. If all the elements are present, okay, so we'll return true, and if one of the element is not found in the hash set, so we'll return false. Okay, so the time complexity of this solution will be O of n for adding and O of n for checking. Okay, O of n for adding the array1 element into the hash set, and O of n for checking that array2 element one by one into the hash set. Okay, time complexity will remain O of n. Okay, then first of all we have discussed the brute force approach, then we have discussed the better approach by using sorting and binary search logic. Okay, then we have discussed the optimized approach by using hashing technique. Okay, by using hash tables. Okay, so that's it. Hope you like this video. Make sure you like, share and subscribe to the channel. So that's it. I'll see you in the next video.